Hello, this is the luckiest maths teacher in the world. Thanks for watching as we go through Venn diagrams. So Venn diagrams, for our purposes, they're just used to organise information to make probability calculations easier. So you've probably seen them before. So they look like this. So you have a big rectangle here, and that represents the universe, the set of all possible outcomes. Then we have two circles, and I'll call them A and B. So A and B, they're sets of events. So let's say, for example, I asked everybody in the class whether they like soccer, football, or both. So I could call A could be all the students who like soccer. B could be all the students who like football. And then outside of the Venn diagram will be students who like neither. So just so we get some terminology right, so the first circle there is A. So this area in the middle we write as A intersection B, and that's what this little symbol there means. It looks like an N a bit. So that's A and B. So what goes in there are things that are common to both A and B. So if it was students who like soccer and football, all the students who like both of those would go in there. So outside of the Venn diagrams, we have all the students who like neither soccer nor football. So this line at the top there means not. And this symbol here means or. So the first symbol we went through, the N meant and this little U kind of thing means or. So all the people outside the Venn diagram are not in A or B. They don't like soccer or football. So we call this whole area inside the two circles together, we call that A or B. So everybody who likes either soccer or football or both is somewhere in that Venn diagram. So let's look at how we could actually use this in solving a probability calculation. So let's say, for example, I'm going to choose my universe, so that's all this, you sometimes call it epsilon. I'm going to call it numbers less than or equal to 10. So I'm going to look at whole numbers less than or equal to 10. So A is going to be the set of prime numbers that are less than or equal to 10. And B, the set of even numbers that are less than or equal to 10. So I'm going to put each number between 1 and 10 into this Venn diagram somewhere. So let's start with the number 1. It's not prime and it's not even. It's neither A or B, so it goes out here. So the number 2, well, that's both prime and even. So I'm going to put it in the middle here. So it's in A because it's prime, but it's also in B because it's even. The number 3 is prime, but it's not even. So I want to put it in A, so it's in the A circle, but not in the B circle, so somewhere over here. So then we go again. Number 4 would go in B, but not A. And then we have 5, 6, 7, 8, and then 9 is out here. And of course 10 is in B as well. Okay? How easy was that? So what we can do is use this to find probability calculations. Now what we normally do is, instead of writing, all of the objects that are in that set, we just write the number that are in that set. So I can redo my Venn diagram down here. So I've got A and B. So we just put in the numbers, and they should add up to 10 because there are 10 numbers all up. So there are 2 numbers that are in neither A nor B. In B, but not A, we have 1, 2, 3, 4, so I'll put a 4 there. We have 1 number that was in both, and then there are 3 that are in A, but not B. And 4 plus 3 plus 1 plus 2 does equal 10. So I can use this in probability calculations. Now, so how would I do that? So let's say that I pick a number at random between 1 and 10, and I want to find the probability that the number is not prime, but also not even. Okay? So instead of going through and thinking, which numbers are prime, which numbers are even and all that, we can just look at our Venn diagram. So this is the same as saying, what is the probability that the number I picked between 1 and 10 is not in A, but also not in B. So there are 2 such numbers out of 10 in total, and that gives us 1/5, okay? So let's say I wanted to find the probability that the number I picked was prime. So the probability, that's the same as the probability that the number's in A. So it's not 3/10. Yes, there are 3 in A, but not B, but there's also this one here is also in A. So the probability I pick a prime number is 4/10 or 2/5. So what's the probability of not being in B? So this thing here means complement or not. It's another way. I could have also written it with the B with a line over it. So the probability that the number is not in B, the probability that the number is not even. So I have 1, 2, 3, 4, 5 numbers that are not in B. So the answer to that is just 5/10 or 1/2. So what is the probability that if I pick a number between 1 and 10, it's a prime number and it's also an even number? Well, that's easy from our Venn diagram. There's only one such number. So that would be 1 out of the 10 numbers in total. Fair enough. So I'm just going to show you how to do one word problem now. Please pause and copy down if you need this. So let's do this question here. In a class of 30 students, 15 like soccer, 13 like football, and 5 like neither. And I want to find the probability that if I choose a student at random, they like soccer but not football. So hopefully now you're asking yourself, well, what's actually going on here? There were 30 students in total, but 15 like soccer, 13 football, and 5 like neither. So 15 plus 13 plus 5 is 33. How can you possibly have 33 students? There were only 30 to begin with. So this is why a Venn diagram is so helpful, because it's not obvious from this question how many like both, how many are in just one of the categories. So that's why we draw the Venn diagram. So we'll draw up our Venn diagram here. So the first circle I'm going to let be soccer, and the second, football. So all I'm going to do is put the numbers in each category in here. So because there are 33, if I add them all up, the only way that's possible is if I've double counted 3. There are 3 too many. So what that means is that 3 people must like both, okay? So I'm too far over. The number I'm over is what goes in the middle. There are 3 people who like soccer and football. So there are 5 that like neither, so 5 go outside. That's easy. So it says 15 people like soccer. So I've already got 3 people who like soccer. 3 of those people also like football. So there must be another 12 that go in here, because these 2 numbers have to add up to 15, because there are 15 people in this circle. So in the football, we do the same. There are 3 who like both. So we've already counted 3 of them. So there are another 10 that go in there. So there are 13 people that like the football circle in total. And what you'll see now is the number in the Venn diagrams, so 12 plus 3 plus 10 plus 5 actually does equal 30. So now we're right. Each student has been counted once and only once. So what is the probability a student chosen at random likes soccer but not football? Well, that's just over here. These are the people who like soccer but not football. So the answer is just 12 out of the 30 in total. And we can simplify that to 40% or 0.4 or 2/5. Either way you write it is fine. All right, hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.